Welcome to Brain Vision.
Hi everyone, this is the solution to problem 40, chapter 24 of Cottonell's Physics. So here we are given three scenarios which we're going to solve in order. So let's start. But the idea here is that you have some incident unpolarized light that comes onto a polarizer, and then you want to find, and then it goes on to meet with an analyzer, and then you want to find what is the intensity of light coming out on the other side of the analyzer. So on the other side of the second Polaroid that you put into the system. And so the incident intensity is going to be an again unpolarized light that has an intensity of 48 watts per meter squared, and alpha I'm always going to be taking to be 30 degrees, and so every angle that we're going to see in this problem is going to be multiples of this alpha value. So let's begin. So we have S0 coming in, it's unpolarized, and it goes through this polarizer, and so as it comes through the polarizer, it's going to have a polarization that is parallel to this line over here, which is the axis of the polarization, and it's going to have a value of, so in here, it's going to have an intensity that is a half times the incident intensity. And this is because it was unpolarized on this side, but now it's polarized on this side, and so it loses half of the intensity. Now, as the wave propagates further, it moves on to the second polarizer, but we see that the axis of polarization is the same on the second Polaroid as on the first one, and so all of the polarized light that exists in the middle is going to go straight through the second polarizer, and so everything is going to come out, and so we're going to have the same thing here. S bar is going to be coming out here in its full glory, and it's going to be equal to half of S0 bar, and so this is 24 watts per meters squared. So that's the answer to your first one. Second question, if we had the same scenario, but now the orientation of the polarizer were different, so let's say that you have the unpolarized light of intensity 48 watts per meter squared coming in on the left, and now there's a Polaroid that polarizes it 30 degrees away counterclockwise from the vertical. So in the middle, you're going to have light that is polarized like this, parallel to this axis. But what's going to happen here? So again, the intensity in the middle is going to be S bar is going to be half of S bar 0, because we had unpolarized light on the left and we have polarized light on or in the middle on the right of the first Polaroid. And so the question is, what is going to be S bar here on the other side of the second Polaroid? Sorry, it's not S bar 0, it's just S bar over here with the red. So what is this equal to? And so the answer to this part is actually quite simple. This is going to be 0 watts per meter squared. And the reason for that is because this blue polarization axis, or this first polarization axis, makes a 90-degree angle with the polarization axis of the second Polaroid, which means that the wave that comes in here is actually oscillating at 90 degrees with respect to the Polaroid's polarization axis here, which means that all of the light is going to be plucked out. And so this is going to be the answer to the second problem. There is no light coming out on the far right of the second Polaroid. So that's the second part. And so the last part is going to be the most involved one, really. So here we have the same scenario. Again, in the middle here, you're going to have S bar, I'm going to call it S bar middle. This is just going to be half of S bar 0. And again, this is because the light on the left was polarized, but the light on the right side of the first Polaroid is already polarized. It's polarized at this angle, which is parallel to the polarization axis over here. Now this polarization axis, so I'm going to try and draw a parallel line over here, is actually making an angle with the polarization axis of the second Polaroid that is also equal to alpha. And so the light that's coming out of here is going to be parallel to this second polarization axis. And so this is going to be S bar right. And so this is going to be the intensity that was in the middle times cosine squared of the angle that this polarization axis makes with the other one. And that angle is alpha. And so just working this out, we have that S bar middle is a half of S bar 0. And then we also have to slap on this trigonometric factor here for the polarization, for the relative angle between the two polarization axes. And so this works out to be 18 watts per meter squared. So that is the answer to the last.